Now, we are going to learn the method that we call reduction of order and the Cauchy-Euler equation. The difference between the method that we do at the beginning and now it is different in the sense that the coefficient in front of the y term and the differential term of y will always be constant. But with this method, it no need to be constant. It can be a function. Okay, so let's see the first one that we call the reduction of order. Usually we use this method with the second order differential equation. The way that we do is just that we are going to assume this such the way that we can reduce the order of differential equation into one, like reduce one at a time. If you have second order differential equation, we are going to reduce that equation to be the first order differential equation. And in order to do that, we are going to divide this type of equation, this method into two different methods. The way that we classify it depends on the variable which is inside the equation. Okay. We say case 1, our equation just in this term. We have the first derivative of y and second derivative of y, but we don't have y. We have second derivative, first derivative, and we have x. Okay. If you look at the equation and then you see only these three parameters in your differential equation, the way to do the reduction of order, you've got to assume p is equal to dy by dx. So in that case, dp by dx would be equal to the second derivative of y. So that means your equation, you have second derivative. By using this assumption, you can reduce the order of your equation from second order to first order. Okay, let's take a look at the example. If you see here, this problem, the coefficient in front of the second derivative of y is not a constant anymore, it's an x. So that means from previous method, can you use to find the answer? No. We said that, okay, this equation is non-homogeneous second derivative differential equation, second order differential equation. And then we said that, okay, then we got to find yc and yp, right? And then we said that, okay, to find yc, you've got to set this equation equal to 0. But now your characteristic equation has x in there. So that means you can find yc from the previous method, right? Now we are going to use the reduction of order to solve for the answer of this differential equation. Now if you take a look closer in this equation, you have x, which is our dependent variable, and we have second derivative of y and the first derivative of y. and we don't have y, which is our first case. If you see that, you got to assume p is equal to dy by dx. And from that, you would get dp by dy, dp by dx is equal to the second derivative of y by x. And then you just put these two definitions into our differential equation. And then we would get x dp by dx minus p equal to 4x to the power 5. And then we make the coefficient in front of dp by dx equal to 1. This is what? Linear differential equation, right? Because this is a linear differential equation, you've got to use the linear differential equation to find the answer. So in order to find the answer of this differential equation, we have to what shall we do? Find the integral factor, integrating factor. I'm sorry. So our integrating factor is 1 over x. And then, so we use our formula 1 over integrating factor times integral integrating factor qx dx plus c. Now, our integrating factor is equal to 1 over x, so that means we got x here. 1 over x times 4x to the power 4 dx plus c. X there. Integral 4x to the power 3 dx plus c. X there. X to the power 4 plus c. I put this one as the c1. Okay. So that means we got our p is equal to x to the power 5 plus c1x. But we know that our p is equal to dy by dx, right? Because we defined it, we assumed it at the first time, at the beginning of the problem. And then we do it again. Now, we just reduce it into the first order. And after we got p, and then we do integral one more time, we would get the answer. P is equal to dy by dx. Okay, and then we do integral again. We just do integral for both sides, we would get x to the power 6 divided by 6 plus from this, you got both yc and yp, right? How do you know that which part is yc and which part is yp? The term that you have c1 and c2 is the general solution. The term that you have the constant in front is the particular solution. Any questions?